Now we want to talk about the linear inequality. So before we talk about the linear inequalities, I want to introduce the interval notations for inequalities. So here, if we have x is greater than or equal to a and less than or equal to b, then we can write this one as a and b. We use bracket and use the comma to separate a and b. That bracket means the endpoint a and b are included. So if we use the line, right? If we use the line, that means we locate a and b and use the brackets. That means x is between a and b, and the endpoints are included. So now, if we have x is greater than or equal to a less than b, so b is not included. So here we use the parentheses. And on the line, you can see we located a and b. The a is included, so we use bracket. B is not included, we use parentheses. The same thing for x is greater than a and less than or equal to b. So b is included, so we use the bracket here. A is not included, we use the parentheses. For this one, x is greater than a and less than b, both endpoints are not included, so we use the parentheses. So on the graph, we locate a and b and we use the parentheses. That means x is between a and b, but the endpoints are not included. X less than or equal to a. So a is included, but less than, it could be as small as possible, right? So it could be negative infinity. So we use the negative infinity because on the other side we have no endpoints. So we use negative infinity, and the negative infinity, we always use the parentheses for the infinity or negative infinity. So here we locate a and draw an arrow. It means less than or equal to a. A is included, so we use bracket here. So x is less than a, the same thing. We use the parentheses for the negative infinity, and we use the parentheses for a because a is not included. So here we locate a and x is on the left side of a. X is greater than or equal to b, so that means b is included, but x could be as large as possible, so there's no upper bound, so we write as infinity, and this is the parentheses. So here is b, we locate b on the number line, right? Then x should be on this side, on the right side of b, and b is included, so we use the bracket here. X is greater than b, so b is not included, so we use the parentheses, right? We use the parentheses, so here is the parentheses, right? X is on the right side of b. So when you have an interval notation, the left number is always less than the right number, so keep it in mind, right? This a is must less than b. Here is negative infinity is must be less than a, right? And here is b is always less than infinity. Now I want to look at the linear inequalities. So the linear inequality is always given by this kind of things: ax plus b less than c. This kind of inequalities means this one is not an equal sign, which is a less than or less than equal to, less than or less than equal to, or greater than or greater than equal to. All right. So we want to solve this linear inequalities for x. So in other words, we still want to isolate x on both sides. Isolate x. Okay, so the idea is still very similar to the linear equation. We can subtract or add a constant for both sides. Okay, it will not change the inequalities. However, the difference is here. Here is if you multiply or divide by a negative number, it will reverse the direction of these inequalities. Less than becomes greater than, or less than equal to becomes greater than equal to if you multiply or divide a negative number. However, if you multiply or divide a positive number, it will not change this inequality sign. So now let's look at some examples to help you to understand. So here is the one example. 7x plus 4 greater than 6x plus 11. The same thing, we want to isolate x, x terms. So we subtract 6x on both sides. So you will have 7x minus 6x would be 1x plus 4 greater than 11. Then we subtract 4 on both sides, so x is greater than 7. So if we want to use the interval notation to represent this result, this would be our result. So it's greater than 7, 7 to infinity or positive infinity is the same, but 7 is not included, so we use the parentheses here. If you use the line graph, this is our number line x. X is greater than 7, so we locate 7 here, for example. Right? So this is 0, for example, this is 7. And we use the parentheses. Right? And this would be your answer. Okay? So now let's look at another one. Six 16x minus 4 greater than 4 times 3x minus 2. Okay? So here, the first thing, we have the parentheses. The first thing we need to do is to get rid of the parentheses. So this would be this example, another example. 16x minus 4 greater than 12x minus 8, right? We distribute 4 for each term. Then we subtract 12x, so it would be 2x minus 4 greater than, we subtract 12x on both sides. So we subtract 12x on both sides. You can write a little letter to help you to understand. So it would be negative 8, right? Then we add 4 on both sides, so this would be 2x greater than negative 4. So we divide by 2 on both sides. So since we divide a positive number, so it will not change divided by 2 on both sides. It will be. So here, what is the sign? Because we divide a positive number, so it will not change the direction of this inequality. So it will still greater than. Okay, so the interval notation is negative 2, comma, positive infinity, parentheses. The number line graph would be we locate, if this is 0 here, so we locate negative 2 here, but negative 2 is not included. We use the parentheses, so this would be our line graph for this solution. So now let's look at another problem. We want to solve a double linear inequalities. So what does this mean? So here is the example, which is negative 20 less than equal to negative 3x plus 1 less than equal to negative 8. Here, so this is called the double linear inequalities because in this inequality we have two sides. Right? So how to solve it? We still use the same idea. The first thing, we want to isolate x. So here x is in the middle. No problem, because both sides have no other x. So we want to eliminate constant 1 here. So we subtract 1 for each term, for each side. Okay? We subtract 1 here would be negative 21 less than equal to negative 3x less than equal to negative 9. It will not change the direction of the inequalities because we just subtract a number. So now we want to isolate x. We need to divide by negative 3, right? So we need to divide by negative 3. Divide by negative 3. Divide negative 3. So since we divide a negative number or multiply a negative number, we have to reverse the direction of this inequality. So this less than equal to becomes greater than equal to. Less than equal to becomes greater than equal to. So this would be 7 greater than equal to x greater than equal to 3. In general, we always like to write x is greater than equal to 3, less than equal to 10. We always, for our convention, we always put the smaller number on the left side and the bigger number on the right side. So the interval notation would be 3 and 7. Here we use the bracket because the endpoints are included. If you use the number line, so this is x. So here we need to locate 3 and we need to locate 7, right? And x is between 7, 3 and 7. And the endpoints are included. So here we use it. Next, we want to solve some formulas for specific variables. So here is one example. 7x plus 10y equals 19. We want to solve it for y. Solve it for y. So in other words, we treat x as a constant and y is the variable. So we want to solve it for y. We need to isolate y, right? We need to isolate y. So here is we subtract 7x on both sides. So this would be 10y equals 19 minus 7x. So we subtract 7x on both sides. Then we divide by 10. So y equals 19 minus 7x divided by 10. So this would be your answer, right? Another one is the f equals 9 over 5 times c plus 32. We want to solve it for x for C. So C is the variable. So F is the constant, right? So we subtract 32 on both sides. So you have F minus 32 equals 9 over 5 C, right? Then we multiply, so we want to isolate C, right? So we multiply, or divide 9 over 5 on both sides. Divide 9 over 5 on both sides. Okay, so this would be C. Let's simplify a little bit. So we always write C on the left side, right? C is equal to, so we divide a fraction. It's equivalent to C. We multiply by the reciprocal of this fraction. So it's multiplied by 5 over 9. So this is your answer.